So what we're going to review today is a general biology midterm. We'll go over some key concepts, and if you have any questions in addition to whatever I'm going over today, just let me know in the comments below. So let's start with question number 1. Charged particles that move around in an atom's nucleus are, we know electrons are negatively charged, so it can't be that. Protons is the right answer. An atom could be an ion, but an ion doesn't exist in a nucleus, so C is obviously incorrect, and neutrons are not charged at all, so that would be incorrect. The correct answer in this case is B. Number 2. Each element has its own characteristic atom in which A, its proton number is constant, B, its electron number is constant, C, the neutron number is constant, or D, the mass number is constant. A, the proton number is constant. That's true. So each element is characterized by how many protons it has. That's how the periodic table is organized. So this could be correct. Its electron number is constant. The electron number we know is not constant because atoms could become ions, which means they gain or lose electrons. So we know B is not the correct answer. The neutron number is constant. Neutron number is also not constant because we know that different isotopes of different elements are basically the same number of protons but different number of neutrons. And the mass number can't be constant because if the neutron number is changing, the mass number, Mn, is number of protons plus number of neutrons, right? So if this is already changing, there's no way this could be constant. So that can't be the answer. The answer here is A. Number 3. The sodium ion Na contains 10 electrons, 11 protons, and 12 neutrons. What is the mass number of sodium? So we just determined up here, the mass number is number protons plus number neutrons. So we have 11 protons, 12 neutrons. The mass number is 23. So C is our answer. Which of the following valence electron numbers would describe the element that is least reactive, most stable? The stability of elements or atoms depends on its valence shell. We know that the smallest amount of electrons you could have in a valence shell is 2, and then after that it is 8, which is whenever you achieve 8 electrons in the outermost valence shell, you are said to have achieved noble gas configuration, right? So A would be the correct answer here. You usually don't see more than 8 electrons in the outermost layer. 5. A covalent bond between two atoms is likely to be nonpolar if A, one of the atoms is much more electronegative than the other, B, two atoms are about equally electronegative, or C, if two atoms are the same element. So we're looking for nonpolar bond, right? Nonpolar means the even distribution of electrons. Well, not even, but like equally shared distribution of electrons. So if one atom is much more electronegative than the other, then they will not be equally shared, so A cannot be the answer. The two atoms are about equally electronegative. That would be equal sharing, so B could be a contender. The two atoms are of the same element. If they're of the same element, then they have the same electronegativity, so they will be sharing the electrons the same. So B and C is correct, so our answer over here is D. 6 of the elements most common in living organisms are carbon, oxygen, hydrogen, nitrogen, sulfur, and phosphorus, right? All of the atoms above are neutral. They do not have any charge. How many electrons does phosphorus have in its valence shell? Okay, so here we get this configuration of phosphorus. They say 31, P, 15. This is our mass number. This is our proton number, right? Proton number, and they also tell us that the atoms are neutral. So if this is our proton number and the atom is neutral, then we would also have 15 electrons. Our first shell has 2 electrons. Our second shell has 8. 2 plus 8 is 10. We have 15 electrons. So the next valence shell would have 18. We haven't quite hit that. So how many do we have after 10? So we get 15 electrons minus 10, 5. So there's 5 electrons in our valence shell for phosphorus. What is the atomic mass of sulfur? So if we look above, they say 3216 S, right? The atomic mass of sulfur. This is our atomic mass right here. So 32 is our atomic mass for sulfur. Number 8. A radioactive isotope of carbon has the mass number 14. How many neutrons does this isotope have? So if we look at here, carbon is C12-6, right? So the radioactive isotope has a 14 here. We know that our proton number can never change in an atom or element, so this will remain 6. How many neutrons? We know our mass number is our protons plus neutrons. So if we know that our mass number is 14 equals 6, which is the amount of protons, plus neutrons. So neutrons equals 8. We have 8 neutrons in this isotope of carbon. A triple covalent bond would A, not be possible, which is not true. We've seen triple covalent bonds. Involve the bonding of 6 atoms. Interesting. Produce a triangularly shaped molecule. Interesting. Involve the sharing of 6 electrons. Okay. So each covalent bond is the sharing of 2 electrons. Covalent bond sharing 2 electrons. So a triple bond would be 2 times 3, which is 6 electrons. So D is correct. Now I'll tell you why the others are wrong. We know that it is possible, so we cannot say that a triple covalent bond isn't possible. We've seen it in carbon as well as many other atoms, in between many other atoms, involve the bonding of 6 atoms. That's not true. What a triple covalent bond is bonding between 2 atoms, but the sharing of 6 electrons, not 6 atoms. So this part right here is what makes answer choice B incorrect. Produce a triangularly shaped molecule. It does not produce a triangularly shaped molecule. If you look at the 3D geometry of a triple bond, it's basically locked in. In a 3D field, this is a very linear molecule. It's not triangularly shaped. So it is D. 10. A cation has gained an electron. So what is a cation? A cation is a positively charged atom. So if you're positively charged, you can't gain an electron. If you gain an electron, you're going to be negatively charged, so it can't be A. Is more likely to form in an atom with 7 electrons in its valence shell. So to achieve noble gas configuration, you need 8 electrons in your valence shell. If you have 7 already, you only need to gain 1 to get to 8. You're going to be more likely to steal an electron from another atom than to give up one of your own. So B is not very likely to happen, and if B is not happening, D is not happening. A cation has a positive charge, which is true. That is the definition of a cation, a positively charged ion. On the other side, an ion is a negatively charged ion. Okay, let's continue. Questions 11 to 13. Choose from the following answers to identify the types of bonds in this diagram of a water molecule interacting with an ammonia molecule. A would be hydrogen bond, B would be polar covalent bond, and C is non-polar covalent bond. We know a hydrogen bond is a form of a van der Waals force, which is not a covalent bond. It's the interaction between 2 separate molecules. So 11, they're pointing right here at these bonds between oxygen and hydrogen. These are not van der Waals forces. These are actual covalent bonds. So it can't be A, it has to be B or C. Now, is this polar or non-polar? Oxygen, as we know, is a very electronegative atom, and hydrogen is not. So this is going to be an unequal sharing of the electron. It's going to result in a dipole. So the oxygen is going to have the electrons more than the hydrogen most of the time. So this is going to be a polar covalent bond, and the answer is going to be B here. 12, it's referring to this interaction between these 2 molecules. And because this is not a covalent bond depicted by the solid lines, we know that this is going to be a hydrogen bond. A hydrogen bond is an interaction between 2 molecules where hydrogen is interacting with an oxygen, nitrogen, or fluorine. And in this case, it's interacting with nitrogen. So we know this is a hydrogen bond. So this is going to be A.